Hi, my name is Shivani Patel. It is October 3rd, 2025, and my molecule is ibuprofen. My molecule is ibuprofen, and I chose this because ibuprofen is something that we all use, whether it's used for sickness, pain, fever, or etc. And it is something that is readily available, and it's commonly used throughout a lot of medications. So it's something I was very interested and curious to learning about and understanding the cryality of ibuprofen. So when you look at the image above, it's going to show the two different sides of ibuprofen, the molecule, and it's also going to show the IUPAC molecule. While that's writing out, I'm going to say the full name of it. It's going to be, for the left side, 2S-2-4-2-methylpropane phenylpropanic acid. And then on the right side, it's going to be 2R-2-4-2-methylpropane phenylpropanic acid. And a common name for the molecule itself is ibuprofen. Nothing too complex, but when you see it all written out, you will see that it is a similar structure. The only difference really is the cryo center, and you will see that the cryo center is due to a single one for the cryality of ibuprofen. It's also known as a stereocenter, and it is a carbon atom that is bonded to 4 different groups. It's going to be a hydrogen atom, a methyl group, a carboxylic acid group, and then a 4-2-methylpropane phenyl group, which is also a benzene ring with an isobutyl chain. So that's going to be the rest of the formula. Sorry, there's a little moving around, but you will see that they are very similar. It's just really that cryality center. You're also going to see now that a purple circle, it's going to show up the different functional groups of ibuprofen. It's just something important to note as we move forward. Now we're going to determine the cryo center priority groups and explaining the configuration. So you're going to look on the left side of the S. Number 4 is going to be that wedge hydrogen that is bolded, and your oxygen that is double bonded to the carboxylic group, it's going to be your highest priority. Since we know that it is a S structure, we're going to be going clockwise. So the benzene isobutyl group will be 2, and then the methyl group will be our third because it is a wedge dash. So it's like technically behind the hydrogen, so it is a little bit lower. When you go on the right side, the methyl is going to be the first one since it's a bolded dash. And then our benzene isopropyl group will be our second priority. Third priority is that carboxylic group, and the hydrogen is going to be 4. It is it's the weakest in the priority. And then also something to know about this structure, they both are antimeres. And that's something important to know. And it's very important when you are looking at the different priorities, you're looking at the different molecules, and that's why, and the wedges, it's important to note that. So thank you so much.